Hello and welcome to Systems of Linear Equations and Linear Quadratic Equations. Linear quadratic equations are what we're going to focus on more than regular linear equations because we've already done systems of linear equations this year. But just as a review, you should know that the solution to any line, any equation, is the line that satisfies that equation. So if you're looking at the 2x plus 3y equals 1 that they give you here, this graph is the solution. That's all of the pairs x, y that satisfy the equation. If you're given two equations and you're asked to find the solution, it's where they intersect. So let's look at the next page. Well, these are two equations, and that's where they intersect right there. That is the only solution, because that is the one place that they actually intersect. They could intersect nowhere because they're parallel, or they can intersect everywhere because they happen to be the same line. So let's review how to find a solution to a system of equations. Now you have two methods to solve these. You can use elimination or substitution, and it depends on which one you are going to do. So let's just do the left one, okay, this left equation. You can do the right one by yourself if you want. But in this case, it would be easier to use substitution to solve this because we have y equals and y equals. So they're already solved for you. You don't have to solve for a variable, which makes it easier to just plug in. Because remember, substitution is taking an equation and replacing it. So we're going to take the 1/2 x minus 2 and plug it in right there. So we get 1/2 x minus 2 instead of our y equal to 5/2 x plus 2. And we go from there. So we need to make sure that, I don't know about you, but I like positive numbers, so I'm going to move my x's to the right and subtract that 1/2 x. And 5/2 minus 1/2 is 4/2. Well, 4/2 is the same thing as 2. Now we still need to get x by itself, so let's get rid of that 2. So that 2x equals -4. And then divide by 2 to make x equal to -2. But we're not done, because once you find x, you have to take it and plug it back in. So I'm just going to take it and plug it back into this equation that I plugged into the first one. And it doesn't matter which one, since they're both solved for y, they're equally easy to do. So we are going to do y equal to 1/2 times our x, well, our x is -2, minus 2. Well, 1/2 times -2 is simply -1, and -1 minus 2 is -3. So our solution here is -2, -3. So let's check this by graphing. And when you graph it, you should solve for y every time. But because these are already solved for y, we can just start with our y-intercepts and go from there. If we're graphing the first line, y equals 5/2 x plus 2, the y-intercept is 2. So we start at 2, and then we use the 5/2. Remember, that's up 5, rise over run, right 2, or down 5, left 2. Now because of the limitations of this screen, I'm going to go down 5 and left 2. So 1, 2, 3, 4, 5, 1, 2, and that's my line. So I can draw, and assuming you have a ruler, right, we want straight lines. I don't, but there you go. Now the other equation, the 1/2 x minus 2. Well, minus 2 is our y-intercept, so we're down here. And 1/2 is up 1 over 2. So up 1 over 2. Up 1 over 2, or down 1, left 2. Well, look at that. Let's draw our lines, and the solution is in fact -2, -3. And that's really what you do whenever you have quadratic linear systems as well. The process is just a slightly bit longer, and you have to make sure you check it. Now, we technically checked it by graphing, and you can do that. But you also need to check graphically if you're not going to check, or algebraically if you're not going to check graphically. So let's look at that with quadratic linear systems. So here, what if you have a system of equations like this? We want to find all x, y points which satisfy both equations. Without graphing, we use substitution, and that's why I did the substitution example, to get whatever we need. And then we solve, and they factored. And I'm probably going to end up factoring 2 because it's much easier to do. Or if you like, you can use quadratic formula. Now here is the solution to that problem that they just showed you. And as you can see, we have a quadratic. We have a parabola in the purple, crossing the linear function, that's the blue, and it crosses at 2 points that they found right there and right there. Okay, but it could have the same types of solutions that we have with regular linear functions. It can have 0 solutions where they don't touch at all, but they're not going to be parallel this time because we don't have straight lines for both of them. We could have 1 solution, it could touch 1 time and that's it. Or it could have 2 solutions and touch twice like the example that you just saw. So let's give you some more examples to see this. Now, step 1 is to substitute. And we're going to substitute in the problem that looks prettiest to substitute in. Because, if you look here, the quadratic functions in all 3 of these cases are already solved for. So, for y. So in example 1, we're going to take the 9 minus x squared and plug it in right there where you see a y. So you end up with 2x plus that y equals. So we have 9 minus x squared equal to 10. So now we just need to start solving. And the easiest way to do this is to put it into standard form where it equals 0. Now, when you have a positive on the outside and you distribute it, nothing changes. So we get 2x plus 9 minus x squared equals 10. But we need to reorder this. So what we should probably do is go ahead and move everything to the right side. So let's add x squared, subtract 9, and subtract 2x. Okay, so add x squared, subtract 9, and subtract 2x. Now we will get 0 on this side. We end up with a positive x squared, 10 minus, then we have a negative 2x, and 10 minus 9 is positive 1. So let's go ahead and factor this. Well, when we factor this, we end up with factors. We do our cross method, 1 goes on top, negative 2 goes on the bottom. Factors of 1 that add to negative 2 are negative 1 and negative 1. So we get x minus 1, x minus 1, which means that the only solution is positive 1. Okay, that's the only answer we will get. So we need to take that positive 1 and plug it back in right there. So we have y equal to 9 minus x squared. Well, we have 9, 1 squared is just 1, and that equals 8. So the only place that this should cross is at 1, 8. But let's just be sure that it works for the top equation, the 2x plus y equals 10. So we have 2 times 1 plus 8 equals 10. Does that really work? Well, yes, because 2 plus 8 equals 10. So when we graph it, like it tells us to do here at the bottom, we end up with this interesting picture, right? And you can graph this in your calculator, that's perfectly fine. But we end up with this kind of picture. And then the other equation is that line. So it does go through 1, 8. It's just, my picture is not perfect because it's a sketch, right? It tells you to sketch it. But if you want to make a very, very pretty picture, which I'm sure both myself and Ms. Hudson would like, you need to make sure you graph at least 3 points on your piece of paper, unless it specifically tells you to sketch it. Okay? And this says to sketch what appears. Alright? So let's do another one of those. Alright? Again, we're going to use substitution. And the first thing you do is substitute it in to whichever one is easier. So we're going to take this x squared plus 6x, and we're going to plug it in right there. So we get x plus that. So we get x squared plus 6x. And that equals negative 6. But we need to make sure that everything's on the same side. So we have to distribute, right? And it's just that positive, so we still have the x, and the positive doesn't change a thing. But now we have like terms, right? We have two x's over here. So those add up to 7x. And standard form means that we have to make this equal 0. So let's add 6 to both sides. And we end up with x squared plus 7x plus 6. And again, I'm going to factor it again. So you can use guess and check, or you can do the cross thing, right? We get 6 on the top, 7 on the bottom. Factors of 6 that add to 7, oh, that's 6 and 1. So our factors are x plus 6 and x plus 1. Those equal 0. So in order to solve, we need to set them equal to 0 and solve. So when x plus 6 equals 0, you subtract 6, and x equals negative 6. When x plus 1 equals 0, you subtract 1, and x equals negative 1. So there are your answers. Those are your x's, but we need to plug in both x values into our original y equals equation in order to get the points, because our answer is not just x equals anymore. It's an entire point in which it crosses. So let's do that. We end up with y equal to the x, so let's do negative 6 first, squared plus 6 times negative 6. Well, that means that we have 36 minus 36, which is 0. So one of our points is negative 6, 0. The other point, y equals negative 1 squared plus 6 times negative 1. And we end up with negative 1 squared is just 1, and then 6 times negative 1 is minus 6 equals negative 5. So our other point should be negative 1, negative 5. So let's graph this and check. So our picture in this case does have it crossing twice, and we end up with this parabola. It's a little bit off. And then that line where, hold on, let me redo this. We have 1, 2, 3, 4, 5, 6. More like that. And then the line, and let's pretend that they cross because I'm not an artist, but they do cross at the correct points. So I'm going to do this one more time. And I know it's getting a little bit long, but bear with me. This is the last thing I'm doing. We're going to plug in the x squared equation right there this time. So we have 4x minus x squared equal to x plus 3. Now again, my goal is to make everything positive, so I'm going to move this x squared to the other side and subtract the 4x to move that to the other side. So those become zeros. We end up with x squared. We have an x minus 4x is negative 3x, and then a plus 3. Now, let's try factoring. Alright, so at the top we get 3, at the bottom we get negative 3, and is this factorable? What are factors of 3 that add to negative 3? There are none. Okay, so this is not actually an option, so let's not do that. Instead, let's use a useful tool that we learned while using quadratic formula, which is the b squared minus 4ac. If you want to know if something is going to have a solution, do that. Because we know that if we end up with a negative number here, that it's not going to have any real solutions. It's going to have two imaginary solutions, which means it will not touch. That's what that means. So our b is negative 3. Our a is 1, oops, and our c is positive 3. So we end up with negative 3 squared minus 4 times 1 times 3. Negative 3 squared is 9, and negative 4 times 1 times 3 is negative 12. Well, that gives us negative 3. That is a negative number for our discriminant, which means we have no real solutions. So it does not cross. They do not cross each other. It's the zero solutions options. So we can see that, oops, by coming down here and graphing it. And if you were to graph this on your calculator, you would get a graph that looks something like this, where the parabola is down here and the line is up there, and they do not cross. So that is completely accurate. So now make sure you're ready next class to solve systems of linear quadratic lines. Have a good day.